So now we come to para 5, network. The steps to run the network are as follows. First point, new transactions are broadcast to all the nodes, and this is enabled on gossip protocol. So gossip protocol basically refers to a specific type of P2P communication that takes place between computers and other digital devices, and this was basically coined by the conventional form of gossip that is pretty much common within the social groups of humans. So the concept of gossip communication can be illustrated by the analogy of office workers spreading rumors. So it's a simple example that every hour the office workers they get together around some water cooler, or they get together for some tea break, etc. So they automatically start at random and they share the latest gossips, and that gossip spreads like wildfire. So what I am trying to bring out here is that it is not exactly like a rumor, but this is the analogical comparison of the gossip protocol on which it is designed, more of randomness algorithm. So for now, we'll just move ahead. So this first point, new transactions are broadcasted to all nodes, is enabled on gossip protocol. More simply, each node collects new transaction into a block. Absolutely fine. That basically means that each node is syncing with the newest transactions across the network. Each node works on finding a difficult proof of work for its block. So this refers basically to the miners. Any node which is interested to mine, interested to compete and find the nonce. So basically there is no boundation, there is no limitation that this node will be able to mine or not. So it is each node is been given the power to broadcast and calculate the proof of work. So the fourth point is that when a node finds the proof of work, it broadcasts the block to all nodes. So this simply means that each and every node which is there on the P2P network participating in the Bitcoin blockchain, so each node has got a responsibility to broadcast any new proof of work which it comes across exactly in the same manner using the gossip protocol. The same thing is replicated just like transactions. So like transactions are broadcasted to all the nodes with the gossip protocol. So similarly, when the node finds a new proof of work, it immediately broadcasts the same to its peers around. The next is nodes accept the block only if all the transactions in it are valid and not already spent. Basically referring again to the point that the blocks are connected, the hashes are fine, the root Merkle tree hashes are absolutely okay. So nodes express their acceptance of the block by working on it, creating the next block in chain using the hash of the accepted block as the previous hash. So absolutely fine. So this is all what we have already discussed, and this is being realized in form of a network. Nodes always consider the longest chain to be correct one and will keep working on extending it. If two nodes broadcast different versions of the next block simultaneously, some nodes may receive one or the other first. In that case, they work on the first one they received, but save the other branch in case it becomes longer. The tie will be broken when the next proof of work is found and one branch becomes longer. The nodes that were working on the other branch will then switch to the longer one. Although this has been discussed in about 6-7 lines, but this has a complete ecosystem of mechanics, and this mechanics has been discussed in videos that I have brought out in the playlist blockchain concepts. But the crux is of this particular paragraph, nodes always consider the longest chain to be correct one. So this is all based on a premise, on the premise of certain conditions being met, that the complete network of Bitcoin, the complete nodes of Bitcoin, they are working together. Each node has got a responsibility in terms of checking the current state of network, checking and when it starts populating its own node, before populating its own node, it verifies each and every block hash. So again, it boils down to the fact that the complete thing is enabled on verification of hashes, matching of hashes, matching of Merkle roots, so all together of them. And then it is also mentioned about the longest chain. So now I'll take few minutes on the longest chain. So longest chain is like a number of nodes are participating across the globe, Suppose there is a successful block which has just been mined. A successful block has just been mined. Imagine this. Now once a block has been mined, once it has been put into the blockchain as the last block, as the fresh block, then the complete nodes across the globe, they start working to find the next block. Now when they start to find the next block, it is not necessary that everyone would join the same blocks of chain. There may be a possibility that they all have different chains, they all have different forks, they will all sub branch from the same blockchain which is already currently running. So while they sub branch, while they branch in different manners, in different numbers, all these branch, they keep doing indexing their block, they keep committing their computing power so that each block is mined, new blocks are mined. So suppose there is a blockchain and the new block has just been mined. So now what will happen is number of nodes will again work together, they'll identify their respective blocks, and each block may have different transactions, they may have different sequence also, but the longest chain which comes out, as you see in the figure, what I'm trying to explain here, as the longest chain which comes out joins basically the main blockchain. So I'm not sure if I've been able to justify this paragraph, but when you see the video deliberately about the longest chain, about the concepts of blockchain, it takes time to assimilate all this. And these are just 9 pages, of course, but at the onset, when you are reading it for the first time, you have to have a belief that not everything will be understood at the first read. So it takes time. So let's read ahead now. New transaction broadcasts do not necessarily need to reach all nodes. As long as they reach many nodes, they will get into block before long. Block broadcasts are also tolerant of dropped messages. If a node does not receive a block, it will request it when it receives the next block and realizes it missed one. So now this basically means that new transactions, whatever are happening globally, they need not reach all the nodes, all the millions of nodes. They need not immediately reach all of them, because by the time they reach all the nodes, most of them would have been indexed in some block which are being attempted by the miners globally. So there will be a scene like transactions are happening globally in all different countries. All these transactions are being indexed into respective blocks, and these blocks are those blocks which are still vying to be indexed into the main blockchain. So once they get into the main blockchain, all the transactions inside that block are considered to be confirmed. And all the block broadcasts, they are also tolerant of dropped messages. So one odd transactions which are missed, so it is fault tolerant, because in case one of the transactions or few of the transactions or few hundreds of the transactions which are happening, they get missed out in some block, then they will be definitely taken in one of the next blocks. And in case any of the transactions, they have to be indexed into some blocks on some kind of priority, because it may take for a transaction to be indexed in a block few minutes or more than 10 minutes, 15 minutes, 20 minutes at times. In such cases wherein some kind of priority is required so that they get indexed quickly, here the provision is that in case they need to be indexed on priority, then the mining fees, that can be on a escalated note. So if a mining fee is higher, there are high chances that these transactions will be indexed on priority. If the mining fees is offered high by the node, then there will be chances that the transactions which have taken recently, they will be accorded priority, because the miners would always look forward for any kind of transaction which is offering more mining fee than the prevalent ones, than the existing ones. So with this we come to the end of paragraph 5, and next we will move to the paragraph 6 in the next video, that's titled incentives. Thank you very much.